All right, page number 3, last page. Use the following information from 15 and 16. The graph y equals a bx is decreasing and passes through the point 0, 4. What is the value of a? Well, if you think about it, when x is 0, b to the 0 power is just 1. And so that means if it passes through the point 0, 4, a has to be 4, because 4 times 1 is 4. I mean, it's basically like saying, 4 equals a b to the 0, and b is 1, right? So that would be like 4 equals a times 1, but a times 1 is just a, so a equals 4. What are the possible values for b? This is where you need to just remember that if it is decreasing, b has to be a fraction. So there's a range of possible answers for b, and the way that you would write that, the way that you would say in math speak that b is a fraction, is you would say b has to be above 0, it can't be negative, and less than 1. Because if it's between 0 and 1, it's going to be a fraction, and the thing is going to decrease. This is more like, I don't know. You just have to remember that if it's decreasing, the b is between 0 and 1. All right. 17. We got the volume of a regular pyramid is 1/3 the area of the base times the height. So there's a mouthful right there. The volume, they're telling us, is 1/3 the area of the base. We'll just call that a big capital B times the height. And they gave us that information. Okay. If the base is a square with width 5xy squared. So let's just stop right there. The base is a square and the width is 5xy squared. All right. What do you know about squares? Let's just stop right there. This is the bottom of this pyramid. We're looking down at the bottom on the top, from the top. The width is 5xy squared. And it's square, then all these sides have the same length because it's a square. So if we want to multiply the area of this square, we just do, 5xy squared times 5xy squared. And if we do that, what we end up with is 25 x squared y to the 4th, right? 5 times 5 is 25. X times x is x squared. Y squared is y to the 4th. All right, now we can start working on this right here. They say, what will the height have to be? Ooh, they're asking us for the height, so we're actually solving for h. For the volume to be 125x cubed y cubed. Okay, so what this is saying is 125, because they're giving us the volume. They're not giving us the height. They're giving us b and h, and we're asked to solve, v and b, and we're asked to solve for h. So we got 125x cubed y cubed equals 1/3 times this, which we just found, 25 x squared y 4th times h. A lot of letters in there. A lot of letters, right? So what I like to do to get rid of the fraction is multiply everything by 3. But so if I multiply both sides by 3, the 1/3 goes away. Hopefully that makes sense. But I'm just going to leave my answer like this for now. I'm going to say it's 3 times 125x cubed y cubed equals 25x squared y to the 4th. I'm not going to multiply that out, even though it wouldn't be too bad, because we can do some simplifying now. Okay, to solve for h, right, all I have to do is divide both sides by 25 x squared y4, right? If I do that, these guys are going to undo each other right here. And now I've got h equals this mess right here. Okay, so now we're at the simplifying part of it. What's 125 divided, this is why I didn't multiply the 3 out. What's 125 divided by 5? That is 5. 125 divided by 25 is 5. 5 times 3 is 15. So there we go. That would be this part right here reduced. What about x cubed divided by x squared? Well, that's just x. What's y cubed divided by y to the fourth? That is y to the negative 1. Now they didn't, in the problem, they didn't specify, they didn't say I had to write that in positive exponential form. So I can use that as my answer right there. If it was a positive exponent, I would just have to put that y in the bottom. So yeah, that one's pretty messy there. There's a lot of letters in that problem right there. You have to be careful with the algebra. Okay. 18. How much money is in an account that earns 6% compounded quarterly? If 10,000 is the initial deposit, there are no withdrawals or additional deposits for 10 years. All right, so here's the equation for that. A equals, this is from the book, P times 1 plus R to the T. And so all we have to do really is just remember this formula and plug everything in. What's the P? Well, that's this $10,000. That's the initial deposit. So that's P is 10,000. Okay. What's the R? Well, that's the 6%. So we have to be careful here because they told us that it's compounded quarterly. All right. Quarterly means 4. So we'll have to do a little bit of adjustment to the rate there. The rate is, it's 0.06 divided by 4 because it's going to be compounded quarterly, right? So that's actually going to equal, if you divide it out, 0.06 divided by 4, it's going to equal 0.015. All right, and now here again we have to be careful with the time because they said, okay, this is 10 years. But again, if it's compounded quarterly, that means it's 4 times. The T is going to equal 4 times 10 because it's 4 times every year for 10 years. And so that actually turns out to be 40. That's the trickiest part of this problem right there, is the quarterly part. 40. And here is where you're going to need your calculator. So this equals, 10,000 times 1.015 to the 40. Remember to do your exponent first and then multiply by 10,000. And if you do, what you should end up with is $18,140.18. There you go. Okay, 19. If Medicare costs the federal government $430 billion in 2010, and Medicare costs grow at an annual rate of 13% over the next 50 years, what will the cost of Medicare be in 2060 if no reforms are made? What's nice about this problem here is the numbers are bigger, but I actually think it's a little bit easier for this because you don't have to worry about the compounded quarterly. They just said it's an annual rate of 13%. So using this same equation up here, all right, we have our principal, which in 2010 we started with 430 billion, okay, so we're just going to write 430 for right now. The rate is annual, so we just do 1 plus 13%, right, which is just 1.13. And then the years, okay, well, how many years pass between 2010 and 2060? 50, right? 2060 minus 2010 will be 50 years. So here is our formula right there. We just need to remember that it's actually 430 billion, right? So you do this number here and plug it into your calculator. What you're going to get is 193,816. Now remember, that's in billions of dollars, right? So I mean, one way you could write your answer is just 193,816 billion. That would work. But to be a little bit more technical, that would equal. Well, let's just write it like that. Let's. I don't want to mess things up. Let's just do that. Let's just say 193,816 billion. Billion. My billion ran over into the problem. Sorry. Okay. Very last one. We got the amount of medication decreases in a patient's body. So this is a decreasing, not an increasing. It's decreasing by 8% each hour. Okay. If a patient took 500 milligram tablet of the medication and then took a 500 milligram tablet again in 4 hours, how much of the medication to the nearest milligram would be in the patient's bloodstream 5 hours after he took the first tablet? Okay. So what we're dealing with here is a decreasing exponential function. So we're going to say that f of t equals a out there times, now 1, it's 8%, right? So that's going to be 1 minus 0.08. And then up here we're going to have the time. Okay, so let's start by simplifying just that expression right there. We're going to have a. What's 1 minus 0.08? Well, that is 0.92 t. Okay, so now all we have to do is figure out, okay, well, what is A and what is T going to be? Well, the A is going to be 500. It's going to be that 500 milligrams. So I'm just going to go ahead and plug that in right now. 500 milligrams times 0.92. And first we're going to figure out what happens after 4 hours, okay, because at first we took the medication, 500 milligrams tablet, again in 4 hours, so we're going to do that part first. 500 times 0.92 to the fourth power. And if you simplify that, you do all your math and you simplify that, what you end up with is 858.2 milligrams. Now the problem is, they're asking, okay, what would be in the patient's bloodstream 5 hours after he took the first tablet? So we need to do this again with an additional hour. Now our A is going to be 858.2 times 0.92, and now our time is just 1 hour. And so you simplify that, 0.92 to the 1 is just 0.92, and then you multiply that by 858.2, and what you're going to end up with is about 789.5 milligrams, which we could probably round up to 790 milligrams. And that is page 3 of the test.